All right.
All right, so overview of today's webinar. We'll talk a bit about the challenge details, and then we'll go into what's required for gateways, talk about the fly sheet, the rock sim, and the virtual presentations expectations. And then we'll finally dive into some project management, scheduling, budgeting, procurement, and we'll also talk requirements. Next.
Then
All right, so now, yeah, go ahead.
I'll jump in. So as we do with all of our webinars, just to make sure you know contact information for all the main people that are involved. Kevin Crosby's our director. Christine is on the line as our assistant director. Uh, I am the FNL project manager. Connie Engberg is on the line as well. She helps with all of our documentation and making sure that we're all squared away. Later in this competition cycle, you'll meet Megan. And then with the First Nations launch, we have Mark and Frank, who are technical advisors for the competition. And then we have extra support from Tripoli with Bob Justice. And I do apologize. The slide deck is going to get updated on when we upload it.
All right. So, and then as we go, feel free to jump in with any questions on any content of the slides. We'll also have some time for questions at the end. I know Jim's familiar with FNL. I'm familiar with Jim. This should be pretty straightforward for Jim but his students, however, are new to rocketry, so a lot of this will apply to them. And Scott will probably get a lot out of this presentation as well. So the Gateway Challenge, the challenge overview, it's designed as a one-semester intro to rocketry. Basically, the Gateway is a stepping stone to the Moon and Mars challenges. We always prefer that new teams or teams that have been out for a while kind of come back and do the Gateway Challenge prior to going into Moon and Mars. So you must understand rocketry before you can really compete in the engineering challenges. We find if a team comes in new and they try to go into Moon and Mars right away without understanding rocketry, the rocketry part is the part that trips them up. There's a lot to understand with high-powered rocketry before you go on and start modifying components and doing all kinds of fancy things, such as our Moon and Mars challenges do. So for Gateway, you will select and build a dual deploy rocket. That's the gist of the challenge. At Gateway Challenge, we also want to introduce you to project management concepts. So it's not just building a rocket. We want you to look at and think about and understand scheduling. We want you to understand budgeting. We want you to think about procurement and then also testing and requirements, which we'll talk about in more detail later. Next. All right, so kit motor selection. The Gateway Challenge again requires you to select one of 3 rocketry kits. So hopefully you've all kind of had a look at the handbook and you understand where to find those kits and you understand the point of the challenge. Keep in mind, it's not an arbitrary selection. I mean, some teams may just, kind of roll the dice and say, hey, I'm going to go with this one because it looks nice. But I mean, in engineering, you kind of examine all the possibilities first. You spend a little bit of time thinking about the performance and the cost and why you would select that kit. Not just based on appearance, not just based on rolling the dice, and we went with this one. So that's something to think about. Trade studies is kind of something that's big in Moon and Mars. The challenge also requires you to select one of 2 motors. So for every kit, we have 2 motors allowed, and those can be found in Appendix A1 of the handbook. So those links there will kind of take you to the handbook. If we could throw those in the chat, I think it bookmarks that location as well. So each kit motor combination has different performance. So if you think about it, there are actually 6 combinations. So there's 3 rockets, and each rocket has 2 motors. There's 6 possible combinations that you could run for Gateway. And then you will also need to use rock simulation software if that's not clear or apparent in our last presentation to run all of those simulations. And then you can use that to determine which kit you want to start with. And Appendix D3 of the handbook has some RockSim guidance. And we'll talk a bit about RockSim later on in a slide as well. Next. So just a screenshot of the handbook. So there's Appendix A5 showing you just a portion of the rocket selection. So Lock Precision is the manufacturer of the rocket. Yank Iris is the name, and it's a 4-inch diameter. So we also include the link there. So if you click on those links in the handbook, that'll take you actually to the vendor's website to purchase that rocket. And then when ordering, remember there's additional components you need to buy. And again, we'll talk about those a bit later. There's a RockSim file available on the website, and we'll point those out as well later in the presentation. And then the motor options are given there, which are also given in the next slide. Next. So Appendix A1 has your gateway motor selections. So as you can see in the table, for every one rocket, there's 2 motor choices. So depending which one you want to run, is a good exercise to kind of examine all the RockSims and all the motor selections and kind of see what the performances are on the baseline. Next. Kit selection. So keep in mind there are numerous kit manufacturers in rocketry. All 3 of our kits are from Lock Precision, but don't let that fool you that Lock Precision isn't the only manufacturer out there. So there's the kit options, links to them as well, and the names of them. You'll need to add in simulation and purchase when ordering another component called the avionics bay. This one's important because teams have missed this in the past, and they have showed up to launch weekend or kind of scrambled at the very last minute to purchase the correct components. So we want to point that out at the start of the Gateway Challenge that you will need to buy an additional avionics bay. And then the link there takes you to the avionics bay that you need to purchase. It's the same bay for any of the rockets. So ensure you get the correct electronics bay. It's a 3.9-inch diameter. And this component will turn your single deploy rocket into a dual deploy. And we'll talk about the difference between those two in the next couple slides. Next. So there's your kit selection. So if you clicked on the Yank Iris 4-inch diameter, it would take you to Lock Precision's website. And this is kind of what you would see. And you can go and add that to your cart. You can see the cost of it there. And then down in the red box, you could also see there's a link to the Iris 4 RockSim. So you would download that file as well and save that. And that's how you begin your simulations for Yank Iris 4. Next. And then this is the avionics bay we mentioned. So this component, and we'll see how this kind of fits into the rocketry in the next couple slides. Just a picture of the avionics bay. The white band is the coupler. It's known as the vent switch band. It kind of goes on the outside of the rocket. And then the brown part is the coupler section that goes in the middle, and it joins the 2 sections on either side. The brown circular discs are wooden bulkheads. They cap each end of the bulkhead. The wooden we call it a sled. The wooden sled there is where your electronics, your avionics go, hence why it's called the avionics bay. They will bolt or screw to that sled, and it all assembles as a sub-assembly called the avionics bay. So make sure you purchase that as well, and you understand how to assemble that. Next. So then single versus dual. A single deploy basically is a 1 parachute. That's why it's called single deploy. There's 1 parachute, a single deployment event. These rockets typically do not fly too high. That's why they're single deploy. And the parachute uses a delay fuse to eject the parachute from the rocket. And there's no electronics needed. So these may fly maybe 1,000 feet. And it's kind of a smaller, rocket, and it's a smaller parachute. It'll go up maybe 1,000 feet, and then you don't need an avionics bay for these ones. It just there's a timer on your motor, just like an Estes rocket, just like the little toy rockets as well. It ejects your parachute at a certain altitude. However, most advanced kits are designed with 2 parachutes, and these are called dual deploys. These rockets typically fly higher than single deploys. And then these usually use electronics to deploy their parachutes, and your electronics are called your altimeters. And the 2 parachute design is basically you'll have a smaller drogue parachute that deploys at apogee. So whatever that is, if it's 2,000 feet or 10,000 feet, you'll have a smaller drogue that kind of allows your rocket to descend almost straight back down to the launch area. You don't want a bigger parachute deploying at 10,000 feet, and then that'll drift your rocket downrange. So you want that drogue parachute And that's why you need the electronics also to deploy that parachute at whatever altitude. You program what altitude you want your parachute to deploy at. And then as it gets lower, you'll deploy your larger main parachute, which will slow it down for a safe descent. And now, since Moon and Mars always use the dual deploy configuration, it's best that the gateway teams also learn the dual deploy configuration. Next. So just a screenshot of a RockSim single versus dual. So you see the image on the top is a single deploy. You guys can't see my cursor. I don't know if Rob's controlling. You can see the single parachute in the middle there, the P with the rectangle. Oh, the P with the rectangle, that's a single parachute. And it's sitting in the booster section. So that's a single deploy. And then notice the front section's kind of empty. There's nothing going on in there. Now, if you want to convert that same rocket to a dual deploy, you would need to buy the avionics bay. Rob, can you circle the avionics bay there with the two bulkheads and the strip? There you go. Yeah, so that's the avionics bay component we just saw in the previous picture. So you would buy that component, and that's where it would sit in the rocket. And now notice you have two parachutes. You have the big P in the front. That's your main parachute. And then you have the little P in the back. That's your drogue parachute. So that's how you easily convert a single deploy rocket to a dual deploy rocket in simulation. And then you can conversely think of the actual, when you buy and assemble the hardware. That's how your flight configuration will go together. Next. All right, avionics bay, we mentioned this, right? So many kits that you see online will be single deploy configuration. So this is kind of a tip if you were to design your own rocket or you were to move on to a Moon Mars challenge. Try and understand the difference between the single and the dual. And does it come with the dual deploy? Does it come with the avionics bay or not? You can always convert your single deploy to dual just by buying that avionics option, the additional option on the website. And then just remember to convert your RockSim. I believe when you download that RockSim file, it's going to be a single deploy only. So in RockSim, you're going to have to convert to the bottom image that we just saw. So you'll need to kind of add some components on there. And then we can help with that. RockSim can also help you guys figure that out. And then just note it. That's why we're sharing this information, because gateway teams in the past have made this mistake and not purchase that component for the dual deploy configuration. So make sure you understand what you need to do and how to accomplish this. Next. All right, moving on to milestones. In any engineering project, of course, there are milestones. These are incremental points where your project should meet partial objectives before proceeding to the next milestone. So your milestones for Gateway, and they will align with the Moon Mars milestones. You'll have a preliminary design in January 22nd, which is next week. You'll have a critical design on February 26th. Flight readiness is April 1st, and your competition launch, of course, is April 29th, the weekend. And then just to kind of lay out what those milestones are, usually in preliminary design or proposal, it's kind of initial concepts, initial components. Maybe you don't have or understand all the things that you need, right? But it's kind of just an outline. It's kind of, hey, maybe we're thinking this kit with this motor, that's kind of what we're leaning towards. And then maybe there's a couple components listed. Critical design, however, it should be the mature and final design. It should be 100% confidence. This is what the kit we want. This is the motor we want. And you should have all your components selected by critical design, February 26th. So about 5 or 6 weeks from now. Flight readiness, April 1st. Your vehicle should be fully fabricated. So between critical design and flight readiness, you're kind of doing the testing and the components and the procurement and bringing that all together to get your vehicle ready for flight on April 1st. And then there's a little bit of a buffer before competition launch, April 29th, when you do your competition. For anything that's procurement that's late or any fabrication that needs to come home, you got that a buffer time in there as well. Next. So data submissions. At each milestone, Gateway teams will submit a fly sheet and a RockSim file. So basically the fly sheet is a summary performance data of your simulations, and it also includes some of your component selections. And your RockSim file is a simulation showing your rocket performance, basically. And we'll cover these a little bit more here in a minute. So at each milestone, you'll also give a milestone virtual presentation. You'll fill out a virtual presentation template, and this allows us to give you feedback after your presentation to kind of, lets us weigh where you are in the entire project. If you need help, if you're ahead of schedule, if you're doing, you're doing fine, the way you are. Next. So fly sheets, you'll download a fly sheet template from the WSGC website at each milestone. There's a link there to the score and rubric page for the fly sheets, and we'll see a screenshot of it here on the next slide, I believe. Each milestone requires more and more information. So it is incremental. So on the very first, fly sheet and the very first RockSim, we don't expect you to knock it out the park. You're not expected to submit, your final product. It's kind of just, the first kind of go around. It's like, okay, well, this is where we've got to at this point. We've spent a couple weeks, this is the things we understand, and then, give us the feedback, and we'll continue to progress and understand a little bit more for the next milestone. Next. So there's a screenshot of the WSGC FNL website. So your first fly sheet that you will submit next week is highlighted there. So notice you'll skip the proposal fly sheet and just use the PDR fly sheet. Note to our admin team, maybe we can add some dates to these the score and rubric page to help the team select the proper file. So make sure to use the PDR fly sheet. Each fly sheet is kind of different, has a little bit of different requirements or different cells to fill out. So the PDR one is where we're at. Next. And then just looking at a section of the fly sheet. So it's going to be a spreadsheet basically, and you're going to fill in the blank cells kind of corresponding to each of those values. So you can see we're going to ask you the vehicle properties. We want to know what's the manufacturer and what's the kit. So your manufacturer will be Lock Precision, and your kit could be the Easy I-65. Total rocket length. So again, maybe you'll go to the website and say, what's the length? Maybe it's 81 inches. You'll put 81 inches in there. Motor properties, for example, manufacturing designation. And then note that the red cells, if you hover over the red cells in the spreadsheet, there's tips, kind of guidance to tell you where to find each of that data from. So, and that's my name on there because, like I said, flags the comment with who made the comment. So your manufacturer motor property will be your team choice. So you'll have to see the handbook, right? Maybe it's an Aerotech I-360 or whatever it is. And then you can see also recovery system components are in there. So you'll list your primary altimeter. You'll list your switch type. We want you to list your drogue parachute diameter. So maybe it's an 18-inch diameter. You put 18 inches in there. Your manufacturer, and we'll discuss this a little bit later, some of the component types for your recovery and altimeters. What else? Some of this data is the data usually comes from either a team component selection. So you're selecting altimeters, you're selecting parachutes. It comes from RockSim data, such as the stability analysis components there, center of pressure and center of gravity. Those values will come from RockSim, or it comes from a website. A lot of your motor data will come from thrustcurve.org, and we'll talk about that. We share that in a later slide. And note that the bold parameters have a required value. So we'll talk about requirements later on. Your static stability margin on the pad needs to be greater than 1. So that's something that, again, we'll talk about in requirements. So keep an eye on the bold ones in the fly sheet, and make sure you understand what that value needs to be. Next. All right, moving on to RockSim simulations. So a lot of your fly sheet data will come from your RockSim simulations. So of course, you're required to procure and utilize RockSim as your rocket simulation software. This is a requirement because we need a consistent tool so that we can kind of compare apples to apples. If teams are submitting different models and different software, then it's hard to compare. So we had to pick one software program to go with. And we also give you enough budget that you're able to procure the rock sim at a discounted rate. Um, so with the rock sim, there's guidance how to procure rock sim in your acceptance letter. There's a discount code, I believe, so you can get a student rate for the year. You can also install and use. There's a 30-day RockSim trial. So while you're figuring out how to procure RockSim, your student should be using the RockSim trial and playing with that. There's also guidance how to install and tips in the handbook, Appendix D3. There's a technical guidance in our RockSim webinar and tools and tips, which we had in, I believe, November. There's technical guidance for RockSim in our Rocketry video series. So the link is there as well. And then RockSim also has support on their website at the Apogee Components website. And then RockSim allows you to understand the flight performance of your vehicle prior to launch. And this also allows you to modify your design to achieve certain performance. Next. So this is just a screenshot of the RockSim program, what it looks like. We don't have time to dive too much into RockSim today. You'll have to kind of go on your own and look at those all those resources there to learn RockSim. Hopefully you've already begun on RockSim. Next. And then just some more notes on RockSim. Your kit, like I mentioned, when you download the RockSim file from the website, your kit may be empty at first. So that basically just means it's really plain. It doesn't have all the components that actually go to the rocket. So you can see, for example, in the avionics bay section that we highlighted earlier, there's nothing in this model, but there should be, right? There should be a sled. We saw, from the picture that there's a little wooden sled in there. That's going to be some weight. We know you want your altimeters in there. That's going to be some more weight. Your bulkheads, even with your parachutes, right? There's some more components that are missing. So keep in mind that the model that you download or start out with is not the final model. You're going to need to kind of make revisions to that week by week as you go and add components. So it's up to you to verify that the simulation represents what you intend to build. Do not assume that the file is complete or accurate. So even once you get the rocket, right, you go and purchase it and it shows up in your lab or your workspace, you may want to measure, the booster tube. Does it actually, match the one in the simulation? Maybe it's a little shorter, or maybe it's a little heavier, right? So you kind of want to do that physical comparison between what you physically have and what's in your simulation. Next. So then your RockSim will mature over time. So starting, at proposal, like we said, it's just going to be a starting point. By flight readiness, FR, by launch weekend, that's when we want your final product. So it's going to change, it's going to evolve. You're going to work on the RockSim week to week and improve and refine those components and the performance as well. So ensure that your simulation accounts for all the internal components. So that's one of the big, I think, problems or issues that I usually see with RockSims is students or teams aren't including all the mass components inside of the rocket. And basically, it's your weight that's going to drive your altitude. So if you're simulating something that's really light and it gets up to 2,000, great. But then once you build it and you start adding all these internal components, it's no longer going to fly to 2,000 now, is it? Because it's got 20% more weight. So make sure you account for that weight in your simulation by using those mass objects. Next. And again, just another shot of a RockSim or a Lock Precision product. And then that shows you the RockSim file to download for the EZI 65 rocket. Next. Moving on to virtual presentations. So at PDR and CDR, you will give a virtual presentation of your status. You'll use the same template that the Moon and Mars teams use. Some of the slide content may not be applicable to Gateway, so you just leave that slide blank, or you can skip the slide. And then this virtual presentation can also be considered practice. You're practicing for launch weekend. On launch weekend, you'll give an in-person presentation to a panel of judges and the rest of the teams as well. So you kind of present and share your work over the year, over the course of the semester with all the teams. But the virtuals, however, you're just presenting to myself, Frank, the admin team, And then we'll also have a few native engineering professionals on the call as well to give you feedback on your presentation and your rocket design. Next. So similar to fly sheets, you'll download your virtual template from the WSGC website, and similar to the fly sheets as well. Each milestone you kind of build a little bit more. So the very first presentation, you're kind of just, hey, we've examined these concepts, or that we've examined these components, or maybe your presentation is, hey, we haven't had time to get to this component yet. We're still thinking, we haven't had time to look at parachutes yet. We'll do that. We'll review that in the next presentation. So the presentations kind of build on each other. Next. And again, the WSGC page. So for your virtual template, that's the file there. You're going to go to the PDR virtual review and download that PowerPoint file. Next. And then that file, it should be about 10 slides, and you'll present to our panel for about 15 minutes. So you simply fill out the content of the slide, and then much of your presentation information comes from your RockSim data or your component selections. So there's some examples there of a previous presentation, and I believe this is a Mars presentation. So you don't necessarily need this amount of detail. It doesn't need to be, all fancy. If you have time, you can add some color or background to it. But just to give you an idea what's possible for the Mars teams there, you can see their launch vehicle performance. They show a plot or a graph from their RockSim data, and they're also listing their performance, their stability, and thrust to weight ratio, and a number of other vehicle performance statistics. So in your presentation, you'll typically end up talking about your kit and motor selection. So which motor you're preferring or leaning towards. You'll talk about your recovery components. So you'll talk about your parachute selections at this point. You'll talk about your avionics components, such as your altimeters and your switches and your GPS. And then you'll talk about your test program and your scheduling and budgeting, your project management. Next. All right, moving on to project management. So project management plays a big part in the success or failure of any project. In a nutshell, project management is scheduling, budgeting, procurement, training, simulations, test plan, requirements. It's kind of all the soft skills, if you were, that helps you achieve the technical objectives. Next. So with scheduling, we'll cover a few of these. So with scheduling, we'll simply provide you with a basic schedule outline to follow. And it's going to be your milestones that drive your schedule. So your milestones kind of determine what needs to be accomplished. So we mentioned a little bit earlier, you're going to have a PDR, CDR, and FR. So your PDR preliminary, you're kind of just, just beginning to look at the design, just beginning to select a kit. And maybe you haven't selected all your components yet, and that's fine. By CDR, however, you should have your final kit motor selection done, and you should have all your components selected. And then FR basically is you're ready to fly. It's kind of built. So that time between the reports there is kind of the goal for FR. And then launch weekend, of course, is when you come to Kenosha, we all get together and fly rockets. And then I also listed some webinars, webinar support and training milestones there. The project management we're doing today. There's an avionics webinar next week. There's recovery, build, and assembly. And then there's also a few webinars that we held in the fall that the team should be reviewing as well, such as a structures webinar and a few other webinars as well. Next. So student role. So for scheduling, right, we see on the schedule there, we start January 1st is kind of when Gateway kicks off. Running to April 29th is the competition launch weekend. So that's kind of 18 weeks, if you start on January 1st down to April 29th. And again, you see your milestones kind of laid out, PDR, CDR, FR, and launch. At this phase, in the mid-January time, your students should be training. So your students should be learning, or if you're a student, you should be learning, what is rocketry all about? So you should be watching the webinars, going on the website, learning how to use RockSim, right? So that's the next student goal there as well. Simulations. So downloading and installing RockSim should be your goal. You see simulations runs for basically the entire project. So you're never really going to stop simulating. You're always you're simulating, you're learning, you're doing your initial designs, you're examining things, you're adding components. Even at CDR, after you made all your component selections, your kit shows up. So now you're going to go and measure and weigh your kit, make sure your simulation matches. So every week you're kind of updating that simulation. After FR, for example, when your kit's actually built, you're still going to make sure that the built kit, the built rocket, kind of matches your simulations all the way up to launch weekend, basically. Other goals, component selections. So starting around now, you're going to start examining, well, which components do we want? Which altimeter do we want? Which recover do we want? And we'll cover a little bit more on components here in a minute. Procurement should kind of wait until CDR, so don't start buying things too early because you may find that, hey, we changed our mind later on, or maybe this part doesn't fit, or maybe this part is too expensive. So make sure you kind of wait a little bit till CDR, until all the entire thing is kind of designed, and all your components are going to fit together, and then you can start in procurement. And then a couple of weeks there running procurement. That's a couple week lead time. If you place an order, you kind of want all of your stuff or all of your items that you procure to show up by FRR. So make sure to account for that in your scheduling. You don't want to procure too late. You don't want to procure too early. Sometimes it helps to understand, how long it takes to get something. How far away is it coming? Is it a special order, right? Does the manufacturer have to make it? Does it take them a week or two to make it before they ship it to me? Other student goals, assembly and fabrication. So once your CDR is complete and your procurement begins and your parts start coming in, you're going to start assembling your rocket, your avionics bay, and your entire rocket together. Next. So advisor role, scheduling as well. So just some tips for the advisor. They should be recruiting students and helping to grow the team in the first couple of weeks, first couple of months up until CDR. At CDR, we have a deadline for launch weekend, and I'm sure the admin team will share more information about that. Usually we can't add students beyond that last week of February to the program. Another advisor objective, if it's not clear, should be procuring your rock sim. So the advisor should be buying those licenses for the students, or helping the students at least get the trial versions up and running on whether it's a school computer, personal computer, and then getting those licenses to the students so they can perform their simulations. The advisors should also be running the team meetings, so making sure your students are meeting on a weekly basis, a recurring basis, at least an hour a week, kind of getting together and looking at your simulations, or reviewing your component selections, or kind of dividing up the workload, who wants to do what, who's in charge of recovery, who's in charge of avionics, who's in charge of simulations. Also just gathering resources. So your team will need a meeting space. Your team may need access to the computer labs at your school. The team eventually will need a space to build the rocket. Starting after PDR, almost up to launch weekend. Any tooling, for example, or fabrication or safety training that you need at the school, it's up to the advisor to get that together for the students. And then also assisting with procurement. So maybe the advisor is the one that actually makes all the purchases. So helping the students, what does the student want, and how do I make that? How do I get them what they need to build this rocket? And then also assisting with travel. So helping them book the travel after the procurements are done to launch weekend. Next. So we talked about some components and component selection. Teams will need to research and select the following components. So inside the avionics bay, we mentioned a little bit, you'll have to have your altimeters. Your altimeters are an electronic trigger to measure your flight performance and inject your parachute at the proper altitude. You'll also need to purchase and examine your switches. So your altimeter is going to need a switch that's accessible from the exterior of the rocket. And you'll also need GPS tracking. So an electronic tracking device to help you recover the rocket out in the field, because there's times where something goes wrong and this rocket drifts, a mile, 2 miles away, and ends up in a tree, and maybe you can't see it. The flight, the Richard Bong Park in Wisconsin in the spring, there's a lot of tall grass. So sometimes your rocket comes in behind the grass and you could walk right by it, 2 feet away, you don't even see it. So we require this GPS tracking to kind of help you guys narrow down and find your rockets in the field. And then other components you'll also need is your drogue parachute. So we mentioned a little bit earlier about what the drogue does, right? It's a small parachute, sits in the aft section. And then you also need your main parachute, which is your larger parachute sitting in the forward section. And then you'll need all the recovery hardware, we call it, such as the shock cords, the parachute protectors, the quick links. So it's kind of, at this point, the student should be examining these options and understanding all of these names and components and what they are and what's the right size and how to go about, buying them. So looking on the various websites. And then you'll also need a motor retention. This is one that a lot of teams also tend to overlook and show up to launch weekend without a proper motor retention. So this component keeps your motor secure in the tube after installation. So you'll insert your motor into the back end of the rocket, but then you need a device that basically either clips or screws on to keep the motor from falling out the back once it's sitting vertical. Next. All right, moving on to project management budgeting. So basically, we'll just provide you with a basic budget outline to follow. So here's an example budget. If I was a gateway team myself, here's my budget. I'm going to allocate rocket kit, and I'm going to list, across the top. I'm going to maintain this spreadsheet and update it week to week. A manufacturer, a vendor, a quantity, unit cost, total cost. And then we also give you some examples there, kind of a website or a link to click each on each one of those. So if you're new to rocketry, you can see the altimeter component, altimeter 1. I selected a MissileWorks altimeter. It's $79, and I'm going to buy one of them. And then there's the RRC3 link there. So we'll make sure you guys get the actual file so you guys can have this budget as an example to help you guys maintain your budgets. So some switches. So these are the major components. There's 2 altimeters. Featherweight is the other altimeter I chose. A little more advanced, $175. Also note in the rocket kit for quantity, I have 2. So depending on your budget, how much you're planning to spend or how much you have, or if your school is donating more budget, you can always go and buy more than what you need. So you're going to need 1 rocket to fly, but maybe you want a spare rocket for a test flight. Or maybe you want a spare rocket because maybe you're worried you're going to damage something during the fabrication or the assembly. It's good to have a spare rocket on hand. $123 for rocket kit's pretty cheap. That's kind of a low budget item, I would say. I feel like the GPS is 2 to 3 times that. So feel free to buy 2 rocket kits or 3 rocket kits. Make sure to spend your budgets accordingly. And then we also have the parachute components in there, like we mentioned, the drogue parachute and main parachute. And then I just have examples kind of listing different manufacturers, Rocketman and Sky Angle parachutes. And then those are kind of just ballpark figures there for parachutes. Your parachute will kind of depend on the size of your rocket. The size or the weight of your rocket basically will determine the diameter of your parachute to satisfy those descent rate requirements. Miscellaneous electronics, miscellaneous recovery. So remember to allocate some budget for that as well. You're going to need some wiring and some batteries. So recovery, you're going to need some swivel and some quick links. Remember to allocate for your build and fabrication. So you're going to need some build supplies, such as epoxy and tooling. You may also need to buy some PPE, right? Some goggles and gloves and some safety equipment so you can build this thing safely. And then your final budget item is your travel. So just whatever's remaining in your budget, or maybe you live close and you guys are going to drive to Wisconsin. I have $2,000 allocated. So you can see my total project cost there comes to about $4,000, which is the entire grant. I believe WCC gives you a $4,000 grant. Yeah. Next. Moving on to procurement. So again, if you're new to rocketry, you may not know where to go, where to look, or what companies are out there, or what websites are out there to help you purchase all of these components, or how to examine and research all of these components. So we put together a little list here of procurement references. So actually, if you start with the red one, I guess that's not a real link because Rob can't click it and put it in the chat. We'll make sure we get you this link. Yeah, go back there. So we see Lock Precision's the first manufacturer, right? And you're definitely going to go to that website because you're going to have to buy the Lock Precision rocket kit. Wildman Rocketry is the next vendor on the list. And just to note that Wildman Rocketry is kind of our, I don't know how you say, in-house vendor. He usually attends the launch weekend in Kenosha in April. Sometimes it's a good idea to open an account or get in touch with Wildman Rocketry for your components because you know that he'll be there on launch weekend. So he can also provide you with any last minute support, or if you need to buy a spare of something on launch weekend, Wildman Rocketry will be in attendance. So check out that website. He should have everything you need for your Gateway Challenge, all the components, the recovery and avionics components. A few other ones there: Mad Cow Rocketry, Chris's Rocketry, and you can see also list a bunch of vendors from different states as well. So maybe that's something you want to keep in mind. Hey, I live in Minnesota. I want to support a Minnesota, vendor. So off we go. Rocketries in Minnesota, and your shipping cost is going to be low because hey, they're like an hour away. I can go pick this stuff up, in person, for example, opposed to ordering from a vendor that's all the way across the country, which may take a week or something to get you your parts. So that's something to consider as well, the location of these vendors. Some electronics are also listed there. For example, in my budget, you saw I had a featherweight altimeter. So check out the featherweight products. Missile Works as well. Those are fairly common. They're in Colorado. Altus Metrum's kind of some higher end electronics, altimeters, and GPS. So if you have some budget to kick around, check out Altus Metrum. Egg Timer is a nice product. Egg Timer comes actually in components. You actually have to solder the boards together with egg timers. So if you're into electronics and you want to assemble the altimeter yourself or assemble the GPS yourself, check out the Egg Timer products. They're a little bit cheaper because you have to do the manufacturing yourself. But if you're into that, the Egg Timer products are nice. And then parachutes, just a couple examples there: Sky Angle, Fruity Shoots, Rocket Man. And then there's some motor data. We talked about thrust curve, getting your motor data for your fly sheet. So the thrustcurve.org link is there on this page. And then for reference, your AirTech motor page is also linked. You won't be buying motors, so don't notice it wasn't in the budget. We will be supplying your motors on launch weekend. And then Cicerone Tech also makes motors. And then other information, the red highlighted one, if you click on the red one from Tripoli, we go to the next page. This is basically, Tripoli has on their website a list of manufacturers and vendors. So if you have that link, you click on that link, this is the page it takes you to. Then you can kind of drill down to whatever, components and vendors, manufacturers you want. Next. Trying to remember how many slides we have left. We're getting close. Project management. So other, at the start, we had all these other project management things listed. A lot of them are more applicable to Moon and Mars Challenge, right? They do a lot of test planning and a test matrix. They do a lot of risk assessment, things that you won't do in Gateway, but just to keep an eye out, keep an idea of. If you want to get into those things and start thinking about those things, those are optional. However, requirements, there are basic performance requirements that Gateway needs to meet with their rocket. So we'll cover those here. They're listed in the handbook, and we verify that you meet the requirements in your fly sheet and Roxen. Next. So challenge requirements. So the screenshot on the image on the right is a screenshot from the handbook. So you see for the Gateway Challenge, right? Your rocket is restricted to those in the list. Your motor is also restricted to Appendix A1 list. And then your altitude target for Gateway. It's a range between 22 and 2,800 feet. And that's AGL, which stands for above ground level. So that will be your simulation goal. You're trying to simulate your rocket to achieve 2,200 to 2,800 feet apogee. And in the real flight, your altimeters will measure that altitude. So when you come back, we'll be able to do a comparison between what you predicted in your simulation and what you actually flew using your altimeters. Next. There's also some general requirements. If you go through the handbook again, there's a screenshot there on the right. minimum of one altimeter, but we always suggest two altimeters. So having a redundant system, having a backup. You also have to have a minimum static margin of 1. So the static margin should be covered in any of the RockSim tutorials. You'll understand a bit better what that static margin is and how you can achieve that. You also need to have a minimum rail exit velocity of 52 feet per second. Again, that's a RockSim parameter. You can get that out of RockSim. And you need to have a minimum thrust to weight ratio of 5:1. This is basically your motor thrust divided by your gross weight of your rocket. So if your rocket weighs 10 pounds, you're going to need a motor that's 50 pounds of thrust. So that's 50 to 10 is 5:1. Next. And then recovery requirements. So your drogue parachute should be selected such that your rocket descends at 45 to 65 feet per second from apogee. And again, you get that value by playing around with RockSim. So if you select an 8-inch parachute in RockSim and you run the RockSim simulation, the simulation will tell you what that speed is from the drogue descent. And if the speed's too high, then the next simulation you need to pick a bigger parachute such that the descent rate matches. And then your main parachute should be selected such that your rocket descends at 15 to 20 feet per second on touchdown. It's the same thing in RockSim. When you select your main parachute in RockSim, it'll tell you the descent rate, and you just need to vary that as well. Next. So keep in mind the list or the requirements I discussed aren't the complete requirements. You need to go on your own and verify in the handbook. I believe it's pages 10 through 20 for all the requirements. So make sure you understand all the requirements. This is our last slide. So for your resources, right, if you need help, please ask. So whether you're a student or you're an advisors, right, if the advisors need help, reach out to us and we'll point you in the right direction. So for your students, ask your advisor for help. You can ask your rocketry mentor for help. You can also ask myself or Frank, who are the FNL tech team. And then you can also ask the FNL admin team, who's Rob, Connie, and Christine. Next. That's all I got. We'll open up to questions.
Yeah, I just want to mention on the egg timer altimeter, this is Frank Noble. If you are going to make one, make sure you're good at electronics and soldering. And if you're going to apply it to your rocket, we need a COTS altimeter next to it also, just to be redundant. Also, I put in the chat a link video on how to assemble your sled that was on the slide. It's a very informative slide. Pretty simple.
No questions, huh? Jim, did I nail it?
I think Jim said that they had some
There we go.
questions.
Yeah, there are a couple of questions. I think Peter's trying to make sure he's got the microphone working. Not coming through yet.
Scott,
Yeah,
any question?
I think his mic has been slow. I've noticed that today.
Put it in the chat.
Hey, Scott, hopefully you've tagged up with Steve Shannon, right?
Yes, we have.
Yeah, Steve's a good guy. Steve's yeah.
Yeah.
He should be able to, he should be enough support to get you guys rolling out there.
Yeah.
Can you guys hear me? I had a question about verifying the Aerotech 38 millimeter I-280 DMS motor. We found the I-280 DM. Is that an equivalent motor for that rocket?
Well, what do you mean you found one?
You mean
On
in the
the
RockSim or?
Yes,
Yeah,
in the RockSim
that's
files.
correct. Yeah,
Yep.
yeah, they just don't put the S.
Okay, sounds good. And the second one is for the motor option for the Aerotech 38 millimeter I-40W DMS was not found in RockSim, but I believe Jim found it on a different site. Is that the correct code for that motor?
Yes, it is. It's a disposable motor, of course. And if you don't have it in RockSim, you'll have to import it from uh, the Thrust Curve website.
Yeah, and that should be covered in our Roxim webinar. Hopefully. I don't know if it was, but it should be. And there's other Roxim resources out there to explain how to import a motor into Roxim.
Yep, it's pretty simple.
Our video series might do it as well. Again, if you're having problems with that, you can reach out to either your rocketry mentor or myself and Frank.
Very good. Thank you.
Anything else?
I did have this other question about where you guys saw most of the previous Gateway launch rockets fail. And the project as a whole, was it in the presentations kind of whether it was short on content for presentations or practice, or was it the actual launch, how that went, or failure to comply with the dual deploy from Apogee and those things?
That's a good question. We've never actually, we don't score the Gateway Challenge, but this year, I think we will be scoring. It is new. We will be ranking teams. I would say, I mean, technically, retention, that's always a big miss if you're new to rocketry. You don't understand that there needs to be a retention or how the altimeters work. We've seen teams try and go and build like a altimeter from scratch using like a Raspberry Pi, and it's like they don't understand that you can just go purchase off the shelf, which is what we prefer. We want you to purchase something that's COTS and reliable and tested. We don't want you to build something on your own because we have no idea if it's going to work, which leads to safety issues, right?
Sure.
So just use all the COTS, use everything COTS you can. Once you prove to us that you guys are good dual deploy rocketry experts, then you can move on to Moon and Mars. And that's the challenges where you get into, okay, now you can build something from scratch. Now you can build your own airframes, or you can build your own electronics. And we'll have a little more confidence that those will succeed. Project management wise, I would say scheduling. Teams tend to procrastinate, or they don't know where they need to be. You kind of early on, they're not really doing much, or they don't know what they're supposed to do. And then the last 2 weeks of the program, all of a sudden everything hits at once, and everyone's trying to spend all this time to get everything done. So it's like, get that scheduling spread out and make sure you're doing stuff early enough to prevent everything from bunching up at the back end of the project.
Okay. Have you seen any tips or tricks that really made a big difference in increasing the quality of the rocket flight or the presentations as a whole?
I would say with presentations, pictures. I love pictures. Again, teams will they'll splatter the slide with text, or they'll have a whole book written on the slide, and it's like, I'm overwhelmed. I can't process all of this. But if you just show one picture of your altimeter, I can tell so much more information from a picture than from a paragraph written on the slide. What was the other part of the question?
Just any tips or tricks that just made a big difference in how teams performed on launching the actual rocket and how that went. I'm new to rocketry, and I haven't talked to Jim all that much about the actual launch phase. So any ideas for making that go as smoothly as possible and having everything ready?
I think, just following the milestones and submitting, your reports and attending your reviews, that will help you be successful on launch day. So you'll have, having all the right components, understanding how all those components work and go together. I don't know if Jim's up for any test launching or things like that out there. We know Jim's kind of familiar with rockets, and he probably has a lot of rockets out there at the school to kind of show you examples of of dual
Right.
deploy rockets from the past. So just make sure you understand kind of everything, all the components that go into it, and that makes it a lot easier on launch day. You show up and you're prepared, and you put your rocket together just like you always practiced. If you practice those steps before you come, you get on the launch pad and you go.
We actually are hoping to do a test launch in Butte before the flight date.
Yeah, attending or observing a launch is also really highly beneficial. So if you're new to rocketry, try and look for a local club in your area. I don't know if Scott's been out to a launch there with his team as well. It's good for the students to just see the whole launch process, how a person puts their rocket together and prepares it for flight, loads the motor, goes out to the pad, right? And just to see those flights, it's exciting and it's inspiring, gets the students fired up.
And don't be afraid to ask questions and don't think you know it all. Be safe.
Awesome. Thank you very much.
No other questions? Scott, nothing?
No, I got nothing.
Scott's gonna ace this thing. He's like, yeah, we're already done.
Well, one of our students is has some OSHA training, and he's already written up extensive safety procedures. So that's pretty cool to see that.
Nice.
Wow.
Yeah, I mean, Scott too, and Jim as well. If you feel like your team's ready and your guys are looking, feel free to go over the Moon Mars stuff. So look in the handbook, look at the Moon Mars challenge, right? And for next year, or just kind of see what kind of work that they do, for example, in their reports, right? And kind of if you want to start preparing that and preparing your team for that, dive right in.
Good idea.
Very good idea.
And Scott, I know your team does know, but Jim, and as you guys are freshly returning, we do have office hours every few weeks. So this Thursday will be the next one from 1 to 3, and it's just an open Zoom meeting for any team members or advisors to jump in with any questions that you guys have throughout.
Oh, good.
So-
I was wondering what that was exactly.
So just a sort of an open extra time for the students, and I tried to have it timed to where it's before a milestone. So in case there's any questions coming up or you guys are sort of curious about what a specific requirement, it would be a good time to be able to address that beforehand.
Should be very useful.
Yes, they are.
And then, of course, if you have any specific technical questions, if you guys know that beforehand, you could always give me a heads up, and then I can shoot a message to Mark and Frank for them to pop in as they have availability.
Great. Thank you.
You're welcome. Gisette, I saw you jump in, but did you have any questions?
Not at the moment. Just listening, trying to get done everything that's needed to be done. Very informational though.
It's a lot, but it is manageable.
Yes.
We got a good 16 weeks ahead of us, so plenty of time to tackle it all.
Definitely.
Right.
Also, if you have any problems with lock precision on ordering stuff or specific items you need, you're having a hard time, you can let me know because they're only like 40 minutes from me.
Oh, that'd probably be one tip as well. So I feel like in the past teams have got hung up on, they contact a vendor and they're like, hey, I'm trying to order this part. The vendor's out, their vendor's out of stock or something. They're usually not the only vendor that has it. So for
Right.
example, Wildman also sells Lock Precision rockets. So maybe Lock Precision themselves are out of stock. They don't have any on the shelf. Go to another supplier, check with Wildman instead of waiting around for Lock Precision, right? check,
Right.
keep going down the list. There's all these other vendors usually carry each other's products, right? So, plan out ahead of time. And like I said, right, maybe you want the local guy, maybe you want to buy your rocket from the local guy in your state, opposed to actually out in Wisconsin, right? Supporting that local business, getting that relationship started, right? To kind of get all your parts from that local guy.
Thank you all. I know we're 10 minutes over, but I just want to thank you all for joining. And then, of course, as you guys have any questions, please don't hesitate to reach out. We're here to help and make sure that everyone has a successful competition year. 31 teams. It'll be a fun day.